A very warm welcome to the session of the embedded system where we're going to learn about the 7-segment interface with the 8051 microcontroller. Okay, so very good afternoon. This is Avinash Das from Skyy Rider. Let's start the session.
Good afternoon.
Yeah, good afternoon. Okay,
Good afternoon, sir.
yes. Okay, let me clear myself first that if you are having any questions or anything, okay, you can ask me in the chat box only. No need to unmute yourself and ask that. That will that will become noisy and sorry, it will break the flow. Okay, so it is preferred that you should talk to me with the chat box. Is that clear?
Yes, sir. Yes.
Okay. Yeah. So first of all, what is embedded system? Okay, embedded system is a combination of software and hardware, especially which is designed for a particular function. Okay. Now, you can say that a computer is a mixture of hardware and software, right? So that computer is a embedded system. Okay, because when you go inside the computer, okay, there is a you can say there is a CPU, right? Inside the CPU, there is a motherboard, and inside the motherboard there are your components are fabricated. Okay, there are a multiple number of components fabricated, and that is known as your embedded system, because all those components are embedded into a single fabric, you can say into a single chip or a single board, where the software is installed or dumped into the hardware, and they are working together to perform a task or perform a particular task and give you the desired output. Okay, then the embedded system can be it can be reprogrammable, or you can say it is one time programmable or fixed. There are some kind of you can say some number of microcontrollers which are you can say which are programmable, or some of them are not reprogrammable. Okay, then when we are going for the history of the embedded system, it is introduced in 1971 in the first microcontroller named as EMS 1000. Okay, and it goes in, sorry, it went to the commercial market in the year 1974. Okay, that is the information that what is embedded system and what when it was invented. Okay, so basically, what is embedded system? It is software plus hardware. It is known as the embedded system, right? Then in the embedded system, there is a thing, or you can say there is a part which is called as microcontroller. Okay, and you can say that the embedded system is revolving around two number of things. Okay, one of is your microcontroller and another is your microprocessor. Though microprocessor is a different subject, but the embedded system is revolving around a term which is known as a microcontroller. Why? Because in a microcontroller you will get a number of things, and in a microprocessor you will not get a number of things. A number of things when added to a microcontroller, it becomes the when a number of things added into a microprocessor, it becomes a microcontroller. Okay, so what is a microcontroller? Basically, a microcontroller is a compact integrated circuit which is designed to govern a specific operation in an embedded system. Okay, so suppose you say that in the computer's motherboard. Okay, in the computer's motherboard, there should be a brain. Okay, there should be a brain which should perform tasks for each and every purpose. Okay, for each and every specific task there should be a brain. Okay, or you can say it is not like a when you go for the hardwares of the CPU, at that time you see that there are multiple number of microcontrollers. Okay, there are multiple number of microcontrollers, and they are used to govern a specific operation in embedded system, or inside the CPU or in the motherboard. Okay, so a typical microcontroller is includes a processor, a memory, and an input output device or peripheral device on a single chip. Okay, so you might not get this. The typical microcontroller includes this and that. Okay, so we're going to get a thorough discussion about that. Okay, so just let's focus on the examples. Okay, so these are some examples of your microcontrollers. So the microcontrollers which we are using, that is your 8051 microcontroller, PIC microcontroller, and ARM microcontroller. Okay, Some of you might have heard the company Atmel. Let me know in the chat box that you guys have heard about the Atmel company, right? Okay, Gopal Krishna, no. Then what about others? No. Okay. Okay. Let me know that how much of you know about the Arduino Uno or Arduino. How many of you know about the Arduino? Let me know. Okay. So basically, Arduino is a circuit. You can say circuit board. Okay. Leave that part. Okay. Basically, Atmel is a company which produces the Arduinos and the ARM microcontrollers. Okay. They are the providers of the ARM microcontroller. Then we got the Peak microcontroller. Okay. Then we got the Peak microcontroller. Peak microcontroller is the advanced type microcontroller. Okay. Which is designed in the Harvard architecture. And lastly, the basic one. Okay. The basic one 8051. The first microcontroller you can say which was designed the modern in the modern way. It is a 8051. Okay. And the 8051 was started by Intel only. Okay. The Intel company, and you know about the Intel i3, Intel i5, Intel Core i5 and all. Okay. That Intel company created the 8051 microcontroller at first. Okay. Then we got the number of things that a microcontroller has. I told you that you will not get the typical microcontroller includes this and that. Okay, so let's see what a microcontroller has actually to offer us. Okay, so a microcontroller has a CPU, which is a microprocessor, then a RAM, a ROM, then an input-output port, a timer, and some ADC or other peripherals. Okay, so in this picture you can see. Okay, a microcontroller. Okay, so assume that this box, okay, this whole box, this bigger box is a microcontroller. Okay, so inside of that we got the CPU. Okay, the CPU which will be executing each and every task. Then a RAM. Okay, a RAM. You are familiar with the RAM and ROM term from your mobiles, I assume that, right or not? Okay, so a RAM and a ROM, then input output ports. Okay, you will be connecting to your other peripheral devices or other devices through your input output ports, because you will be giving data and receiving data. So that's why you will be using some input output ports. That those are the pinouts of a microcontroller. Okay, then we got the timer. Okay, timer for your various purposes like timer and counter, using timer and counter for both different purposes. Okay, then we got the serial communication port and other peripherals. Okay, so these are the things which are resided in the microcontroller. Okay, is that clear? Someone give me a confirmation that you got it from in the chat box. Guys, am I audible?
Yes, sir, audible.
Okay. You got what I right now what I told you? Understood, na? Okay. Till now, if anyone having any doubt, you can ask me in the chat box soon. Okay. I'll be watching it shortly. So let's get to the next part. Okay. So what are the features of a microcontroller? What are the features of a microcontroller? So basically, a microcontroller is used to perform a specific task that needs small resources. That means there are less number of data, okay, or you can say less number of size of the data, and you are executing a task, okay, and that particular task need to be executed carefully, okay. You can't go for a microprocessor which will be used for the general purposes, okay. So at that time you will be doing what? You will be using different type of microcontrollers for different, or you can say specific purpose, or different tasks. There are different microcontrollers, okay. So that is one of your feature. Then it has a small size, or you can say there is a compact size, and there are some examples in where we are using microcontrollers. For the example, we got the keyboard, washing machine, remote, mobiles, cars, and etc. Okay, so these electronic components will have will definitely have a microcontroller. Okay, and then another thing is that it will be low cost comparing to microprocessor. So why is a microcontroller which is residing a microprocessor in itself will be low cost comparing to microprocessors? Because microprocessors are general purpose, and microcontroller is a specific purpose task. Sorry, you can use it for specific task. Okay, so that's why it is low cost than microprocessors. A microcontroller is the heart of an embedded system. Okay, like you can say transistors. Okay, transistors are the building blocks, or you can say heart of electronics. Okay, so like that, microcontrollers are the heart of embedded system. Okay, and the microcontrollers has a very good feature that they consume very less power. Okay, so if you are going to connect a 5 volt into a circuit or a embedded system, that much will be sufficient to activate any of the components there. Okay, if there is any passive components. Then that was for the embedded system and microcontrollers. So we're getting into the 8051 microcontroller. So these are some leading suppliers of the 8051 throughout the globe. There is your number one company, that is your Intel, and second one is your Atmel. Then there is your Philips and Signetics. Then there is your Siemens. Those who knew about the automation, or you can say industrial automation, they know about the Dallas Semiconductor and the Siemens. And those who are from the ECE branch, they know about the Atmel, Intel, and Atmel and Philips and Signets, and everyone knows about the Intel. Okay, so if you want a 8051 microcontroller for your users, you can directly connect to these companies, or if you're going to purchase a 8051, you can go for these companies 8051 microcontrollers. Okay, so there is a little bit history. Okay, okay guys, there is a little bit fun fun task. Okay, just let me know who like if I tell you about the history or not. Okay, because some of you find that the history is very boring. Okay, so let me know. Hurry up. I'll be giving you 1 minute. Okay, let me know if you want to know about the history or not.
No, sir. No, sir. हेलो सर, एक बार प्रिंसिपल को, इसका प्रिंसिपल होता जो
Again,
हाँ प्रिंसिपल होता, वो एक बार और समझा दीजिए बस।
principal na?
हाँ
Okay, just stay with me. Okay. Okay, which one? The features or the construction?
यस
Like the feature or the construction, or both?
जी जी
Both. Okay.
हाँ
When you go for the construction, at that time you will see that a microcontroller is having a CPU, RAM, ROM, input output port, and a timer.
टाइम आउट
With that too, there is your ADC and peripheral systems. Okay, so that is the construction of a microcontroller. CPU, you all know that CPU is used for the what execution purpose. Then there is your RAM and ROM for storage. After that, input and output ports are used for what? Input and output ports are used for generally your data transferring into other you can say other devices. Okay, to connecting other devices. Then timer is used for time, like you can say it can be used as timer and counter. Okay, there is a separate part of a timer. Okay, so till then you just know that it can be used as a timer, the timer which you use, and otherwise the counter. Okay, then there is your ADC and other peripherals. Okay, then there is your feature. So the basic feature of your microcontroller is that it can perform specific tasks. Like for a particular specific task, you will be using a particular microcontroller. Okay, then it is a compact size or a small size. Then there is your keyboard, washing machine, remote, mobile. There are a lot of things in which you use the microcontrollers. After that, it is low cost from microprocessors. Okay, why? Because microprocessors are general purpose and these are for specific purpose. After that, microcontroller is your heart of embedded system, like your, you can say, for your example, your transistor is heart of your electronics. That's how your microcontroller is the heart of your embedded system. Then low power consumption. Okay, low power consumption means your microcontroller will be consuming very much less power than you think. Okay, like if you are, there is a whole circuit and you'll be giving a what you can say, you'll be giving a 5 volt, and then your microcontroller will work. Okay, you will be giving 3 volt, 3.3 volt, your microcontroller also will work. Okay, so it consumes less power. Is that clear?
Yes, sir, clear.
Okay, thank you.
Okay, thank you, sir.
Yeah, because you asked others, those who have queries and they are shy to ask, they are also getting cleared. Okay, so some of you told that a little bit history, some of you told no, and some of you said yes. Okay, so I'll be cutting it short. So basically, it was designed in 80s. Okay, it was designed in 80s, and the first microcontroller which was launched named as MCS 051. Okay, you can write it down or take the screenshot of it, because it is the most frequently asked question in the embedded system in the embedded system. Okay, when you go for an interview. So that is all. Okay, and all these things are about the history, that how it became and why it became, all those things. Okay, because it had a lot of features and all. Then we're directly going for the 7th segment. Okay, 7th segment. What is 7th segment?
सर ए से लेके जी तक का वर्ड एबीसीडी वाला.
Once again.
सर ए से लेके जी तक का वर्ड एबीसीडी वाला.
Yeah, that is your 7th segment. Actually, that is not A from A to G. Okay, that is your you can say you can put any kind of pattern. Okay, you can use any kind of pattern according to your usage. Okay, there will be, I'll be explaining you that what is the 7 segments of your what is that called? Yeah, your 7 segment display. Okay, so just give me 2 minutes. Okay, just give me 2 minutes.
जी सर.
Okay, so basically what happens, you can see this is a 7 segment display, right? Yeah, so this 7 segment display means why it is named as 7 segment display, because the lighting, or you can say the LEDs which is used in this display. Okay, the LEDs which is used in this display, you can say, if you count them, they will be separated in 7 segments. Okay, here is one segment, you can say here is one segment first, A, then second segment, then third segment, then fourth segment, fifth segment, then is your sixth segment and seventh segment. Okay, hope you got it. Hello.
Yes, sir.
Yes, sir.
Okay, so the lighting, or you can say the diodes, are divided into 7 segments. That's why the name of the screen is your 7-segment display. Is that clear?
Yes, sir. Yes, sir.
Yeah. So in today's webinar, or you can say in today's class, we are going to perform a task, and that task will be what? To showing you 0 to F or 0 to 9 in the 7-segment common cathode display with 1 second delay. Is that clear? That will be our task of today. Okay. So first of all, let me introduce you into some of the, you can say, what is that? Some of the tools. Okay. Some of the tools which we are going to use today in this class. Okay. So there will be your two number of softwares. There will be your two number of softwares. What are those? Just a second, guys. Okay, guys, sorry for the interruption. Yeah. So we're going to use some of the tools which is your Keel Supervision, Keel Mu Vision 5. Then there is your Proteus 8 Professional. Okay.
Excuse me, sir. Hello.
Yes. Yes.
सर ये बोल रहे हैं थोड़ा हिंदी में बताइए सर.
हिंदी में.
टोटली इंग्लिश समझ में नहीं आ रहा.
ओके, कोई बात नहीं. ठीक है.
जी
तो
सर.
बेसिकली हम लोग इसमें क्या करेंगे अभी ना, हम लोग कुछ टूल्स यूज करने वाले हैं, मतलब कि कुछ सॉफ्टवेयर यूज करने वाले हैं. ठीक है. वो सॉफ्टवेयर जैसे कि हमारे हो गए, हम लोग यहाँ पे नॉर्मली 2 सॉफ्टवेयर यूज करने वाले हैं. तो वो सॉफ्टवेयर हमारे क्या है? एक है हमारा कील न्यू विजन 5 और दूसरा है हमारा प्रोटियस 8 प्रोफेशनल. ठीक है. एक को हम लोग यूज करेंगे कोड लिखने के लिए. ठीक है. और दूसरे को हम लोग यूज करेंगे सिमुलेशन करके देखने के लिए कि हमारा ये जो मतलब हम लोग जो प्रोजेक्ट बना रहे हैं, ठीक है, इसमें जो कनेक्शंस होंगे एंड ऑल, वो कैसे काम कर रहे हैं और वो काम कर रहे हैं कि नहीं. ठीक है. तो ये देखने के लिए हम लोग इन सब टूल्स का यूज करेंगे. तो फिर अभी देखना शुरू करते हैं. राइट. देखना है कि नहीं, ये बताओ.
ऐसा देखना है सर.
ठीक है. आई गॉट योर एक्साइटमेंट्स. सो लेट्स सी. ओके. तो पहले हम लोग क्या करेंगे, ठीक है. तो ये जो इंटरफेस आप देख रहे हो, ठीक है, मेरा स्क्रीन विजिबल है?
यस सर.
क्या?
यस सर.
ओके. यहाँ पे देखो आप. ठीक है. ये जो इंटरफेस है आपका, ठीक है, ये जो इंटरफेस है आपका, ये है क्या? ये आपका कील न्यू विजन का इंटरफेस है. ठीक है. तो पहले से ही मैंने अपना कोड लिख रखा है. ठीक है. तो बेसिकली हम लोगों को करना क्या है, यहाँ पे आपको एक प्रोजेक्ट है, प्रोजेक्ट में जाना है, न्यू म्यू विजन प्रोजेक्ट. ठीक है. न्यू म्यू विजन प्रोजेक्ट. ठीक है. तो ये आपको फाइल नेम बता लिखने के लिए बोलेगा.
सर एक्सप्लेन इन इंग्लिश सर.
इसमें
हेलो.
यस.
चल टीच मी इन इंग्लिश सर.
ओके.
टीच इंग्लिश सर.
इंग्लिश.
स्पीक इन इंग्लिश सर.
Okay. No issues. I'll be explaining in both languages. Okay. Don't worry about that. So what we'll be going to do is uh, just we are going to open the new project. Then you'll be giving the name. After giving the name, what we'll be doing? Let's suppose I'm giving that only 7. Okay, or 7.c. Okay, it is the extension file name for your C programming. Okay, so I'll be saving 7.c. Okay, see this dialog box will be open. Okay, target 1. Okay, so you have to search your AT89C51. Okay, here it came, AT89C51. Okay, so this will be your, what is that? It is your microchip or your microcontroller. Okay, तो ये आपका क्या है? जनरली ये जो AT89C51 है, ये आपका माइक्रोचिप और माइक्रो कंट्रोलर। ठीक है, तो इसने आपने इसको सिलेक्ट किया, उसके बाद आपको क्या करना है? देन यू विल बी एंटरिंग ओके। आफ्टर दैट no need to copy the starter file. No, see your project or your target is created. Okay, तो तुम्हारा यहाँ पे टारगेट क्लियर हो गया। देन यू विल बी गेटिंग ए सोर्स ग्रुप। यहाँ पे आपको सोर्स ग्रुप मिलेगा, जहाँ पे जाके आपको, ठीक है, ये जो 7.c है इसको ऐड करना। ठीक है, एक बार ऐड कर लिए, देन क्लोज। ठीक है, you added the like you have add the 7.c, then you have closed the dialog box. After that, you can see in the source group there will be a 7.c. Okay, now you have to do what? You will be opening a new project. After that, you can see here, you whatever you will be writing here, you will be writing as a code. Okay, so already I have written the code here. Just let's see. I'm going to files, sorry, going to projects, open project. Yeah, this is a 7 segment. Open. Yeah, so this is my program, and if you want to know that where I got the program, in the PPT there it is also. Okay, so here is the program. Okay, so here is the program. Generally you have to do what? The initiative file. Okay, the initial file, or you can say the, what is that called? That library you will be including, that hashtag include reg51.h, that library you will be including for the operation. Then unsigned integer a and unsigned integer x, you will be including the unsigned integer a and x for your operation. After that, the character data. So what is this character? All this character data. What is all this character data you will be including? So these are the values. Okay, these are the predefined values in all the microcontrollers for your 7 segment displays. Okay, for the formation of 0 to 9. Okay, for the formation of 0 to 9, you will be getting these number of what is that called? These number of character data. Okay, then after that you will be starting your void delay. After the void delay, you will be giving what? X equal to 0, x is less than 20,000. Okay, and x plus plus. Okay, so it is the delay you will be giving in for starting from the starting the program, and after that you will be getting the what is that called? You will be getting the output according to the delays. Okay, so void main, then while 1, while the data will be 1. Okay, so while the x is equal to 1. Okay, that means for a equal to 0, a is less than the size of data. The size of data will be here. Okay, the size of data will be here, and a plus plus, that means the data will be incremented. Okay, that means if I start my program right here, and the while x is equal to 1, at that time your initial data will be 0. Okay, a is equal to 0. Then after that, okay, after that, just a second, guys. Okay, so initially it will be starting from here, it will be 0, and after that, here you can see size of the data na. So this is the size of the data, that will be your 0 formation, and after that a plus plus means it is the incrementation. So the incrementation, that it will be bouncing from here to here, here to here, here to here, and all these formations are in the order that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is the formation. So if you want the code, you can take the screenshot. Okay, and after that, p2 is equal to dat inside the bracket it is a. That means the p2 is what? Here T2 is your port 2. That means the data will be shown in the port 2 here. Okay, so I'll be discussing about the port 1, port 2, port 0, port 1, port 2, port 3. Okay, so no need to worry about that, which one is the port 2. Okay, then delay. Okay, so this delay is for the delay between your, you can say what? See, in the void delay, which delay you have mentioned, that is the delay will be initiated. After that, the voidman will work again and again. Okay, so this is the program, and you can see there here that this is the circuit diagram for the 7-segment interface. Okay, so I'll be directly showing you in the yes.
What do you mean by 0xD0, x610, xbd? What are they, sir? Hello?
Yes. Just a second. Yeah, this one, na? You're asking about these ones.
Yes, sir.
Yeah. So these are the codes for the there are diodes, na? There are 7 number of diodes, right?
Yes, sir.
In the 7-segment display, there are 7 number of diodes, 7 segmented diodes. I have told you, na? Wait. I'll show you. No worries. Here you can see there are 7 number of diodes. You can see if I zoom in this picture. Okay, if I zoom in this picture, these are LEDs or not? Okay, these are the LEDs. Okay, so these are 7 number of LEDs. So these 7 number of LEDs need to be powered up in a manner that it will be getting data. Okay, it will be getting the power in the form of data. Okay, and it will lit up. So to execute that operation, okay, to execute that operation, to perform this task, these are the codes in which you will be providing power to like different kind of what is that called? Different type of diodes, or you can say different LEDs to lit up and make a formation of the numbers. Okay, so that's why these are the codes, or you can say these are the characters are written.
Okay, sir. Thank you, sir.
Yeah. Okay. So okay. So my code is written here. Then after that, what I'll do? Okay, I'll just save this one. Okay, you can say I'll save this one. After that, I will do what? I will simply go to translate. Okay, translate. Translate means here is your, you will be compiling. Okay, in the compilation, there is no error and no warning. Okay, so my code is okay. Then I will be clicking on build. So what does this build mean? Build means you will be creating a hex file. Okay, so now what is this hex file is? The hex file is used for your simulations. Okay, you have to generate hex files for simulations, and after that, when you are going to put that code in your hardware, the hex file is used for working the file. Okay, sorry, working the code, or the sum up of the code in a particular file, which will be used in your simulation and hardware. Okay, so here you can see creating hex file is generated. Okay, so now I'll be doing what? I'll be opening my simulation app, or you can say my simulation software, which is my Proteus. You can say Proteus 8 Professional. Okay, so here you can see I have already made the circuit design, and I'll be explaining you that how I made the circuit design. Okay, so this one is my what? 8089C51. So where you will find it in Proteus. Okay, so you will be going for this components, which is written P here. Then you'll be searching for AT89C51. Okay, see the first one, MCS 8051, or which is your MCS 051. These are the same. Okay, so this one is here. You will be clicking OK, and you will be getting this one. And then again, my you can say common cathode 7-segment display. Okay, so my common cathode 7-segment display is what? You just write here 7-seg MPX1. Okay, according to different kind of you can say according to different kind of your codes. Okay, you can choose your hardware. Okay, that depends upon you. Or if you are going for the original hardware, not for the simulation. Okay, then you can do one thing, that whenever you are getting the hardware, just get some references of the code which you will be going to use, or write the code and check it in the simulation. After that, go for the hardware. Okay, that is the process. So this one is your display, and here is your cancel. Okay, so you have to do what now? See here. Here you can see that there is your P 1.0 from 1.0 to 1.7, 3.0 to 3.7, P 2.0 to 2.7, 0.0 to 0.7. So what are this P 0 point something is means? That means a total number of, if you are going to count, there will be 32 port pins. Okay, 32 port pins, or you can say total number of 40 pins. Okay, there will be total number of 40 pins in your microcontroller or 8051 microcontroller. So apart from the 8 pins, okay, apart from those 8 pins, there will be 32 pins which will be divided. Okay, the input output pins, which are the 32 pins, will be divided in what? The ports. Okay, port 0 to port 0.0 to 0.7, that is one port. Port 1.0 to 1.7, that is one port. Port 2.0 to 2.7, that is one port, and 3.0 to 3.7, that is another port. Okay, so these are your ports. Then how will you connect? Okay, so you have to connect it vice versa. The connection will be from here to here. Okay, when I am pointing the wire, you can see it is lighting up. So the first one will be at the last, then the second one at the second, then the third last one is at the third, you can say 23, fourth one at the fourth, then and so on. Okay, you have to do the
Sir, I didn't see any boards.
What? Once again? Hello?
Sir, I didn't see any boards, circuit boards. It's I didn't see
सर वो
any circuit boards.
स्क्रीन रुकी हुई
Okay,
है
Board is visible, sir. Hello.
okay. Sorry guys. Just a
I
second.
didn't see any circuit boards, sir, on the screen.
Yeah. I'll be getting to you. Just a second. Sorry guys, actually that is a mere interruption. Sorry. Yeah. So
कोई बात नहीं
now is it visible, right?
हाँ हाँ
Right now. So this one is your you can say 8089C51, or you can say the 8051 microcontroller. Okay, in the Proteus 8 Professional. So how to get all these devices? Where you will be getting all these devices? So here you can see this P. Okay, this P, you can it is used for pick devices. You will be searching here.
Sir, no, sir, not visible, sir. Not visible.
Still not visible. Yeah, it is quite visible, right? Till now it is not visible. Let me know. Hello? Hello?
Yes, Avinash, you are audible.
Yeah, my screen is visible, right? I am at the Proteus 8 Professional. Can anyone confirm me that it is visible or not?
Yes, sir, visible.
Visible, sir.
Okay, thank you. So at AT89C51, okay, you will be getting the first one here. Na? This one is your 8051 microcontroller, which I am using. Okay, then once again, this one is the 8, you can see here 8089C51. Then this one, okay, this one is the common cathode 7-segment display, right? So once again, I'm going to pick devices. I'll be searching here what? 7seg. Okay, there are code names. 7seg MPX1. Okay, MPX1. Sorry guys, just a second. Yeah, so 7seg MPX1 CC. This one is my 7-segment display. Okay, so the connection you are watching here. Okay, so this is the mere connection here. You can see that. So these are the ports. Okay, there are 40 pins, and apart from 8 special purpose pins, there are the 32 pins are the input output pins here, and that is divided into 4 numbers. So This one is from port 0.0 to 0.7. This is 8 pins are. What is that? 8 number of pins. Okay. So port 0 this here. Port 1 is here 1.0 to 1.7. Then port 2.0 to 2.7. Then 3.0 to 3.7. So these are the four number of ports. So in the code we are using port 2. So we'll be connecting the port 2 with the circuit. Okay. So the first one here will be connected to the last one. The connection will be vice versa. Okay. So the 21 number, that means the first number, will be connected at the last, and the last one will be connected at the first. Okay. So that's how you are going to do the connection. You can see here I am lighting up. Okay. The wire is lighting up here once again, here, and all this. Okay. They will be connected in the same manner. Okay. These are connecting in the same manner. Okay. And there will be additional pin for connection of the ground. The connection is all okay with you. It is not that much you can say what is that called, difficult of the connection, right or not? Okay. So now we are going to do what? Just a second, guys. Yeah. So I'll be putting my hex file which I have generated in the key software right here in the 8051 or 89C51 microcontroller. So when I'm double clicking on this one, okay, here you will get this kind of component editing dialog box. So here I'll be going for the program file, and here in the program file I'll be searching for the objects. You can see the what is that called? You can see the location of the hex file where it is. You can see it at the key software, and after that you can go there and just click on the hex file. The hex file will be having a extension name of .hex. Then open. That means then okay. That means your code is dumped into the microcontroller. Okay. Now let's see the simulation. If it is showing me the right ones or not. The task is to 0 to 9. Okay. That means in a 1 second delay, I'll be getting 0 to 9. Okay. So let's start. See here. It is working or not, guys? Let me know in the chat box it is working or not.
वैसे वर्किंग हो रही है.
So okay, guys. Thank you
Yes,
for the
sir.
session. I hope you will like this session, and you will be joining us for more sessions again and again. So thank you. Yeah.
Thank you, sir.